Hello, my name is Tiana Staudinger, and I'm presenting research on the mechanisms of the blood-brain barrier disruption induced by methamphetamine. The purpose of this study is to investigate the mechanisms that methamphetamine uses to impact the permeability of the blood-brain barrier. Meth exposure rapidly alters signaling pathways within the central nervous system, and endothelial cells play a critical role in maintaining the blood-brain barrier and regulating cerebral blood flow. Recent studies have indicated that meth increases endothelial cell permeability, which disrupts the blood-brain barrier and amplifies stroke outcome severity. We propose that methamphetamine exposure impacts endothelial cell permeability through augmented production of reactive oxygen species. Methods that were used in this study included cell culturing of mouse brain microvascular endothelial cells, or MBMECs. These were then used in an electrical cell substrate impedance sensing, or ECIS, to assess altered permeability and endothelial barrier function. High-performance liquid chromatography, or HPLC, was then used to measure the production of reactive oxygen species. Under the results section of the poster, the ECIS data was plotted in Figure 1, and the HPLC data was plotted in Figure 2. The results of the ECIS in Figure 1 showed a concentration time-dependent increase in permeability of MBMECs. The HPLC analysis in Figure 2 highlighted an increased production of superoxides at higher methamphetamine concentrations. In conclusion, exposure to methamphetamine resulted in an increased permeability of the blood-brain barrier and an increased production of reactive oxygen species, overall disrupting endothelial cell permeability and function. These results represented a possible connection between the increased reactive oxygen species production and the increased permeability of the blood-brain barrier. Continued research on treatments to disrupt reactive oxygen species production by methamphetamine may reduce neurotoxic effects and improve stroke outcomes in the future. Thank you so much, and I hope you enjoy my research.